Welcome to Tech Talk Simplified. I'm Wally Gustafson, and I lead the innovation team at Reese USA. Today's topic is, what's a neural network? By definition, neural networks are computing systems with interconnected nodes that work much like neurons in the human brain, using a mesh of algorithms that can uncover hard-to-identify patterns and data relationships, and then pull them together and classify them. But this is Tech Talk Simplified. Simply put, a neural network is a computer program that's inspired by the way the human brain works. Our brain is made up of three classes of neurons: sensory, motor, and interneurons. Sensory is what you hear, see, and smell. Motor is how you move your muscles. Interneurons carries messages between sensory and motor neurons. And because neurons all work together, they're called interconnected neurons. A neural network is made up of multiple layers of neurons or algorithms, which is just a fancy word for math formulas. And they work together to solve a problem. Each neuron in the network is responsible for processing specific pieces of information and then passing it on to the next layer of neurons or math formulas until the final output is produced. They perform individual functions but are interconnected and work together to solve a larger problem. Let's look at a super simple analogy of a neural network. In this case, the neural network is represented by an innovation team, and we're creating an image recognition tool. Each member of the team has a specific role to play. We've got a software engineer, we have data scientists working in Python, we've got a front-end developer, we even have a user experience expert. And this team simultaneously works independently on their piece of the tool and collectively to still deliver a final product. What's fun about this is that after creating the image recognition tool, the tool itself has parts that work independently and together to deliver a final answer to the end user. A portion of the IR tool will analyze the photo looking for objects that it recognizes. Another portion of the tool has a special skill of pulling text out of images. It'll then hand that text over to a natural language processing model where it can further understand the content of that text. And in the end, they huddle, compare notes, and come back and say, this is what we found in the image, all in a matter of seconds. Neural networks are used in a wide range of applications, from image recognition, voice assistance, language translation, even self-driving cars use neural networks. By working with and learning from large amounts of data, these neural networks can actually improve their performance over time. Just like how an innovation team might get better at solving complex problems after working together for a while. Let's recap what we learned today. Neural networks are computer programs that use math formulas to independently solve pieces of a problem. The neurons, or math formulas, are interconnected, and they hand off their solution to the next math formula until the bigger problem has been solved. A real-life example of a neural network could be an innovation team made up of different skill sets working on different parts of a project, ultimately, though, working together to deliver a final end product. And that's it. You're a pseudo-neural network expert. Thanks for joining. We'll see you next time.